Hello guys, I am Ayush Bansal and I welcome you to the first video in series on Object-Oriented Programming using C++. Object-Oriented Programming, abbreviated as OOPS, is a paradigm which helps to write reusable, maintainable and flexible code. OOPS is the predominating paradigm in software industry for a couple of decades now. In this series, I'll try to teach you OOPS in an easy manner so you could learn any object-oriented language easily. OOPS is frequently asked in job interviews and exams as well. Before jumping straight into OOPS, let's talk a bit about development history of programming languages. Check out the video description if you want to jump to specific portions of the tutorial. Software evolution started with machine language, the first generation languages which were very hard for programmers to use. The programmer had to type every data and every instruction in the form of zeros and ones, that is, in the binary form. These first generation languages were quickly superseded by second generation languages known as assembly language. The assembly language program contained a series of instructions for the microprocessor. Then came the third generation language. The third generation languages were more abstract and were portable. Means if you write your code on Linux operating system, you would be able to run it on Windows or Macintosh OSs. The third generation started when IBM introduced Fortran in the year 1957. Fortran was introduced for processing complex mathematical formula. In the year 1958, ALGOL was introduced. ALGOL introduced the notion of local variables and procedures. As the program size began to increase over the years, it was very difficult to keep and maintain the whole program in a single file. C was introduced to remove this flaw, and C modularized the code. That means it stored separate modules in separate files, making it easier to manage. C++ is a mid-level language. C++ was originally called C with classes and was developed by Jan Strautstrup in the late 80s. C++ is used in gaming industry in development of OSs and other web applications like Chrome browsers. The development of programming languages did not stop there and is continued to this date. Now, the focus is on developing languages which make it easier to write AI and ML code concisely. Some languages include Octave, MATLAB, and Prolog. These languages make it easier for programmers to write complex operations using less lines of code. For example, matrix multiplication can be achieved using single line of code in MATLAB. Coming to procedural-oriented programming or POP. In POP, the problem is viewed as a sequence of things to be done, such as eating, sleeping, coding, etc. In the diagram, the main program is divided into a sequence of functions, and these functions are defined to complete the solution, and POP employs top-down approach. Coming to our main topic of discussion, object-oriented programming. In POP, the main focus was on writing functions and not on data, which made data insecure. In OOPS, we eliminate this flaw by focusing more on data rather than on procedure. The program is divided into objects. As you can see in this diagram, we have three objects and these arrows show the communication between them. Each object contains data and functions operating on that data, and it employs bottom-up approach. So let us now talk about top-down approach and bottom-up approach with the help of an example. Consider the railway reservation problem, and we want to develop some application for it. Using top-down, we will write separate functions for train, station, passengers and tickets. And these will all solve a specific sub-problem of the main problem. Whereas in bottom-up approach, we will consider all the objects in this problem space and we will define those objects, and at the end we will connect those objects to form the main solution. In a nutshell, in top-down approach, we take the whole and we divide it into parts. Whereas in bottom-up, we take the parts, we define them and we connect them to form a solution. These are the major concepts about which we will be talking today. These concepts are objects, classes, data abstraction, data encapsulation, inheritance, polymorphism, and message passing. Coming to the first concept and the major concept of OOPS, objects. Objects are the basic runtime entities representing the real world entities like chair, student, car. Consider this example. We have one car object and it has some data members like plate number, X location, Y location, and speed. And it contains functions like move, park, and accelerate. These functions operate on these data members. For example, if we consider accelerate function, it will increase the value of the speed variable, and objects are self-contained. It means that most of the data required by these functions is present in the object itself. Let us now talk about classes. Classes are the blueprint of objects, or we can say the template. In this diagram, we can see that the class is the blueprint of a car and objects are the real world entities that are derived from this car class. So we can derive van object from this class, car class. We can derive audio object from this car class. All these objects are derived from the same class, yet they are different in appearances, in specifications, because the data members associated with that objects are different. String str. It means that str is an object of class string. Coming to our next concept, data abstraction. It is the act of representing essential features without including the background detail. It follows rule of least astonishment, which says that the user using your program shouldn't be burdened with details which are irrelevant to him. For example, a car driver knows how to apply brakes, but he does not need to know how the brakes are internally applied and how the car is stopped. Hence, classes are known as abstract data types. Means we are only exposing the features which are required to the outside world. Coming to next concept, encapsulation. In encapsulation, we encapsulate the data and functions. Means we wrap the data and functions in a single unit called class. The data attributes are known as data members, whereas the functions operating on those data members are known as member functions. In this diagram, we can see that we have some private member variables and functions which are not accessible from outside the class, whereas we have some public members which are accessible from the outside. So encapsulation performs three main functions: bundling of data and functions, second is restricting access, and third is providing access to some variables or functions. Let us now talk about inheritance. Inheritance is the act of deriving new classes from existing classes with adding some features. It follows don't repeat yourself principle and it provides reusability. Means you need not start from the scratch. As you can see in this diagram, we have car class which contains properties like wheels, width, height and name. And if we want to derive one class sedan, we will just add additional properties to it like bonnet and power steering without starting from the scratch. Coming to the next major concept, polymorphism. Polymorphism is a Greek word which stands for many forms. It means that a single function will act differently in different situations or contexts. For example, if we have a car and it has refuel method, the refuel method can be via petrol or gas or via electric charging. So the implementation is different in each case, but we only know that we have a refuel method. There are two types of polymorphism, that is static polymorphism and dynamic polymorphism, and we defer this discussion until further tutorials. The last major concept of OOPS is message passing. Be it real world or be it programming, an independent object is of no use. Hence, it is important for an object to communicate with other object for sending and receiving information. Consider this diagram. We have two objects, object A and object B. Object A sends a message to object B requesting some information, and object B returns the information to object A, and all these communications is done through member functions. So if object A wants to pass a message to object B, object A will invoke a public method of object B and pass the data. That's all I have for you guys in this video. Hope you liked it. Please like and comment to give feedback, and suggestion, and please share it with your friends.